Thank you for joining me today. We're going to be talking about solving unit rate word problems. Let's take a look at some content that you'll need to know before we get started. First of all, what a rate is. That is simply a ratio that compares two quantities with different units of measure. Okay, and again, units of measure, miles per gallon, miles per hour, and price per item. When we're talking about a unit rate, what we're doing is we're taking the two measurements down to which the second term is 1. So we're trying to find basically what that means, how much 1 would be per item or how far you're going per mile. So we're trying to take that, what would be a denominator and a fraction, down to 1. All right, so let's take a look then at some examples. The majority of these problems are going to come in word problem form. So this is a bike problem. Jack goes for a 3-hour ride on his bike. He's able to ride 42 miles in 3 hours. If Jack rode at a constant speed the entire trip, what was his unit rate in miles per hour? So we're trying to figure out how far he's going how long it takes him to go 1 mile. So in this case, what we'll use is division. We're going to take the miles, since it's set up as miles per hour. If you know that little fraction that you probably use in word problems, you will see that the miles always go over the hours. Time will typically go on the bottom. So in this case, we're going to set it up as 42 over 3 in fraction form, which again sets up as 3 divided into 42, keeping in mind from earlier slides that we learned that the bottom number divides into the top number always. So 3 goes into 42. We know that 3 can go into 4 one time. Multiply to get 3, and then we'll subtract. All right, bring down that 2, and you're looking at 3 going into 12 4 times. So the unit rate here that we're going to be looking at is 14. All right, and that's going to be 14 miles per hour. All right. The next example here, which I'll clear that away. Okay. On a field trip, there needs to be 3 teachers for every 24 students. At that rate, how many teachers will be needed for 108 students? You actually have a couple strategies you can use here. The first of which would be the same one we just used a moment ago. We can figure out how many students per teacher. Okay, so to do that, we will set up the problem as 24 students per every 3 teachers. And by dividing here, what we'll find out is how many teachers will be needed per student. Excuse me, that's going to be a 24. Sorry about that. So 3 goes into 24. I actually did the math already there. It's going to be 8. So then we multiply and we can see that that works out quite nicely. And what that means then is that you're going to end up with 8 teachers per student. Now, how we will use that now in the context of this problem is we will now use division again with the total number of students that are going on the trip. So there is 108 students, so we will need to divide one more time to figure out how many teachers total will be needed. So we'll go ahead and do that division. 8 goes into 10 one time with 2 left over. We'll go ahead and bring that 8 down. Now 8 doesn't go evenly into 28, but it does go in 3 times, leaving us 24. So when we subtract, we see we have a remainder of 4 there. So in this case, we're not going to deal with a partial teacher, so what we'll do here is go ahead and round up. We're going to round up because we're going to need that extra teacher for those extra students. So in this case, since we have a remainder, we're going to go ahead and round that up to 14 teachers for this trip. Depending on the problem, there will be instances where you may have to round down, but that's all in the context of the problem. So just make sure you're reading the problem and paying attention to what they're asking for. And typically what they're asking for is in this last sentence right here, pretty much every time. All right. The next example here is a grocery store problem. At the grocery store, 6 oranges costs $4.20. If each orange costs the same, what is the price per orange? Okay, so we're going to go back. This one's very similar to the first problem where they're just giving us one type of scenario. So we're going to always, on this problem, take the total amount in money or monetary and divide it by the total number you're buying. So you can see the consistent pattern here as we use a lot of division in these problems. We're trying to divide the problems down to where your denominator is 1. So we're going to go ahead and divide here 6 into $4.20. And from an earlier lesson, we talked about dividing decimals. You need to remember to move the decimal straight up. Make sure you're dividing by a whole number, and we are 6. So 6 goes into 42 7 times. With nothing left over, we can go ahead and bring that 0 down. We're not completely done yet because we don't want you saying that it's 7 cents. Keep in mind, we go ahead and finished off the division even if it is a 0, so that we can see in this case that it's actually 70 cents per orange. All right. So again, depending. There you go, 70 cents per orange. And then the last example here goes back similar to the second one we did, where you have two scenarios going on. We know that we're buying 8 soccer balls for $136. They want to know at this rate how much would 3 soccer balls cost. So 8 soccer balls for $136. I'm going to show you another strategy here. You can use a strategy of proportions. We used this in another lesson earlier on when we were talking about percents. So you can set this up in proportion form, putting the money over the total number of soccer balls originally bought, and set that equal. Now the key to setting up a proper proportion is making sure that you put the like amounts over each other. So in other words, you want to put the money over the soccer balls in this case. Here we have the money. Down here we have the soccer balls. So when you set up your second equation, or excuse me, your second fraction, you need to make sure that you keep it in that order. So it says, how much would 3 soccer balls cost? Well, we don't know the money, so that's our unknown, x. And now we need to figure out how much 3 would cost. So the 3 is the number we're trying to buy, so we go ahead and write 3. We can use the strategy of cross multiplication here to help us out. So we're going to cross multiply, and again, to do that, we learned that in another lesson, that same percentage lesson. You multiply across the equal sign in both directions, like so. So we're looking at 8 times x, which is going to give you 8x. And then you're looking at 3 times 136. If you can't do that in your head, you need to go ahead off to the side and work a little bit of scratch work. So that's 3 times 6, which is 18, carry the 1. 3 times 3 is 9, plus 1 is 10, carry the 1 again. And 3 times 1 is 3, plus 1 is 4. So we're looking at 8x equals 408. So now at this point you're ready to divide. So we're going to divide by 8. So that's going to leave us, and again we divide by 8 in this case, going back to, again, to another lesson. If you don't remember, you divide because you're using inverse operations here. 8 times x, the inverse of that is division. What you do to one side of the equation, you have to do to the other side, which is why I'm doing it to both. So that's going to leave us with just x equals, so that means now we need to divide that out. 8 into 408. So 8 goes into 40. That's going to be 5 times. 5 times 8 is 40. Bring down that 8, and you can see it works out quite nicely to give us 51. Okay, and that's going to be $51. Okay, it also asks in this problem, how much would 12 cost? So really quickly, we'll run through that similar process, same process really, just different values. How much would 3 soccer balls cost? How much would 12 cost? So we're still dealing with the missing monetary value or money value that it would cost. So we're going to set it up the same way in proportion form of 136 over 8 set equal to our unknown value, which is how much it costs, over 12. We're going to use cross multiplication again. So 8 times x, 136 times 12. So that's going to give us 8x for 8 times x. And looks like we'll need to do a little bit of math over here to the side to figure out what 136 times 12 is. So 2 times 6 is 12, carry your 1. 2 times 3 is 6, plus 1 is 7. And then 2 times 1 is 2. Hold the place with a 0. 1 times 6 is 6. 1 times 3 is 3. And 1 times 1 is 1. That's a 3 there. All right, so then once we add everything up, we get 2 and 0. 7 and 6 is 13. Carry your 1. 2 plus 3 is 5, plus 1 is 6. So it looks like we get 1632. So now we're left with the same process. You can see there's a lot of repetition here with these last few steps. You're always going to end up dividing here because that's always going to end up being multiplication. So the inverse again is division. So you're going to divide by 8 once more, leaving you x, 1x, which is what we want. And let's go ahead and divide out 8 into 1632 to figure out how much it would cost. So 8 goes into 16 2 times. Whoops. Let me backtrack there. That's 2 times 8, which would be 16. Now we bring down the 3, but what you'll notice is that 8 can't go into 3, so we need to hold that place up there in your solution with a 0. When we multiply 8 times 0, we get 0. Then we can now bring down the 32, or excuse me, the 2, which gives us 32. And 8 will evenly go into 32 4 times. So your final answer here would be $204. And that's just one other strategy you can use. You could have also used the division strategy to figure out how much each ball costs, and also that was basically the same strategy we used for problems number 1 and problems number 3. So you could have used that here as well. And that is how you solve unit rate word problems. Thank you for joining me.